Hi biology class, it's Mr. Yager and I'm here today to talk about section 11.2 seed germination. Here are our learning outcomes. First things first, we're going to define germination. We're also going to look at differences between monocots and dicots, the importance of venation, the arrangement of vascular bundles, and differences found in germinating plants. Let's get started. Alright, essentially germination is considered the sprouting of a seed, and on the next slide I'm going to give you a bit of a more detailed definition. A couple things I want you to jot down. One thing is that when the environment that this plant is living in is suitable, germination or sprouting of the seed occurs. The environment is key. As you think right now, outside we have warmer temperatures, but in the past couple weeks we had some cold temperatures. That's going to affect germination because that's usually going to take place in the spring. Now, during germination, the embryo will resume metabolism, growth, and development. Now, this is a little bit different. We've been talking about animals for a couple weeks, but we do have a pretty good understanding of what metabolism is, where the plant is essentially going to make and use its own energy. Growth is pretty obvious in plants. You're going to see it grow in height and also width, which we'll talk about in greater detail in 11.3. And then obviously development of its flowers, development of all the sexual parts of the flower. And finally, in this germinating wheat seedling that you guys will see right over here in this right corner, the endosperm and cotyledon are still in the seed coat. Typical monocots, which is defined right here, and we'll look at that today by the amount of the one leaf that it has. Wheat seedlings push their green photosynthetic embryonic leaves out of the soil. Now take a second to think about why that would be important. If you are going to go through the process of photosynthesis, that is how a plant is going to use a combination of sunlight, water, and carbon dioxide to make its own energy. So one of the very first things that a plant will do is to create something to start bringing energy in. Alright, now I want you to put down a definition of germination. What I have here is the sprouting of a seed and time when metabolism resumes. Kind of repetitive what we put down before, but I really want you to understand what sprouting means. That's really going to speak to the growth and the development of this plant. And as you can see here, we have some seedlings in the bottom pictures here, and there are lots of differences, okay? As you notice here on the far left, we have a seedling where nothing is happening. Right now, the environment is not suitable for that seed to go through germination. But we have in other places, we have a little bit of a green growth coming out of this seed, so that is a suitable environment. And as you can see, some seeds are farther along than other seeds. Alright, I'm going to show you a quick video clip on seed germination. As you can see, we have a bunch of seeds put in below the ground. And we're just going to kind of watch this little video clip as it puts a display as they start to develop. So as you can see, they kind of sprout and develop a root system. And then eventually a stem's going to pop out and it's going to push up through the ground. And notice that immediately we have developed some leaves. And I want you to look at those leaves and maybe count them, maybe on one plant, as you can see right here. And notice that there are 1, 2, and those are the very first leaves that have popped out of the ground. That's going to be very important to understand in the next couple slides. In this slide, there is a lot going on, and there's not a lot of words that I really necessarily want you to write down, but it wouldn't hurt to draw a simple picture in your notes. The title is Monocot versus Dicot, and what that's speaking to is this first leaf here, and as you can see, there are some slight differences. Cotyledon is considered the first leaves to appear. And in a monocot, I guess you could basically make the statement that it's not necessarily leaves, but an actual leaf that's appearing. So if you've ever looked at a plant and noticed that there is just one leaf sprouting up out of the ground, you can definitely consider that a monocot. If you see one with 2 leaves, a lot of our flowering plants are going to have that. That would be considered a dicot. So for a simple drawing, I would mainly focus on this picture here for a monocot, which is very easy to draw. And I would focus on this portion that I'm circling over here by a dicot. That's denoting the 2 leaves that are first appearing on this particular plant. So take a second to draw those in your notes. Alright, this slide, nothing really to write down, but I want you to take a look at what is happening. This is going into a far more greater detail than we're ever going to do in this class, and to be quite honest, far more than I ever want to know about plants. But there are some things to note here. I mentioned a seed coat in that first slide. As you can see, this seed coat is a protective coat that's mainly going to be on that plant seed throughout winter, in our case up here in Wisconsin, but also if it has been laid up above ground to prevent certain animals or critters from getting after it. So up top here we have monocotyledon, which we have basically shortened to monocot. We have 1 leaf that's first appearing, and it's pretty evident that that is considered a monocot. Down below we have our dicotyledon, which we have shortened to dicot. And you can really see those first 2 leaves that I'm kind of tapping on here. And they have really developed and grown into a plant. Now, one thing to note is that these cotyledons are actually going to fall off. So you may have experienced this in your life if you've seen, especially in spring, a flowering plant or some type of plant start to grow. And you might see 2 leaves that are real shriveled up. Now they look healthy, like up here in this monocot, as they're beginning to push through the ground, but once you get those major leaves that are going to be used for photosynthesis, these cotyledons will fall right off. Alright, venation. Very important term to understand when we're talking about plants, especially in seed germination. Venation can be described as an arrangement or system of veins, as in the tissue of a leaf. Now in human beings, we probably would consider veins something that blood's going to travel through. The concept is exactly the same. I like to define it right here, as you can see, as a highway for nutrients and waste to be exchanged. Now there are some differences. In our monocots, we have parallel venation. And this is definitely something that you want to do a simple drawing in your notes to take a look at. But I'm going to kind of trace over it off here to the left. Notice that all of these veins are running parallel in straight lines. Okay, that's how monocots are going to grow. A great example is take a look at the grass in your yard, if you have any. You'll notice that you have parallel lines of those veins running up and down the plant. Now again, that's an area where we're going to send nutrients, most likely sugars that we've made through photosynthesis, and exchange some wastes as well. Now we have some differences. In dicots, a great example would be a maple leaf. If you've ever seen a maple tree before, the veins will actually branch out, and we call that net. Okay, net venation versus parallel venation. So your net venation is going to immediately branch out, very similar to how a tree branches out. That way it can evenly distribute all of the nutrients throughout the plant. So again, make sure you have a good drawing and understanding of how venation is important. Now that we have an understanding of what venation is and how it differentiates, I'm going to show you a little video clip. Now what I want you to look for is which example represents a monocot in its venation and which example represents a dicot in its venation. Do 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 do. Whew. Alright, that's over. Alright, what do you guys think? Obviously this last one right here, we have some parallel venation occurring. And remember that parallel venation is only going to occur in monocots. Whereas net venation, which would be represented in the previous picture, and I can kind of bring it back here. We can see right here as this picture moves back and forth. This is net venation, and that's going to be found most notably in a dicot. So hopefully you got that right. Next we're going to look at the flower parts in a monocot and a dicot. As you can see in the images put before you, monocots, the petals are usually in multiples of 3. So as you can see here in purple, we have 1, 2, 3 petals. That would be considered a monocot. Again, probably not a bad idea to draw a simple picture that shows multiples of 3. So your multiples of 3 would be 3, 6, 9 for those of you that can't do math. Dicots would be a little bit different. We're going to see petals in groups of 4 to 5. So as you can see with this image right here, we have a flowering part that has 5 petals, and we consider that a dicot. So make sure you have a little drawing to help you remember what that looks like. Arrangement of a vascular bundle is very important in plants. And we're going to be looking at the stems, which is not the flowering part and it is not the leaf. It's which everything branches off from. And if you take a look, part of the transport system in vascular plants exists in 2 forms. This is probably something that you learned in middle school. The 2 buzzwords you need to understand are xylem and phloem. And thankfully, we're not going to go in that much detail about that, but there's a simple image that I want you to take a look at. Again, we're looking at the difference between monocots and dicots. In a monocot, the veins in the stem have a scattered pattern, as you can see right here. And this is what we consider a cross section of the stem. So if you cut directly across it, very similar like if you were cutting a carrot in half. And the veins will have a scattered pattern in monocots. Now in dicots, it's very different. Okay, the veins are basically arranged what we call radially, which is a circle around the stem. So if you ever have an opportunity, grab a dicot, grab a monocot. We're going to do it in class, but at home, and really take a look at that stem and see how those vascular bundles are arranged. Now, what's the purpose of these vascular bundles? It's very simple. Xylem and phloem are going to be responsible for pulling water and pulling nutrients up out of the ground. And these are highways very similar to the veins we talked about in leaves. But the stem is what's put in the ground. So the vascular bundles and stems are going to bring all that nutrients up from underneath the ground and deliver it to those leaves where the photosynthesis, processes of photosynthesis are occurring. All right, to kind of wrap things up, we're going to look at flowering plants, which are considered angiosperms. And we're going to basically draw out a little chart that talks about the differences or characteristics of monocots versus a dicot. Now, this is obviously information we've already been through. So if you want to do it mentally, that's fine. Again, I always find it very helpful to write this down. And maybe you would even want to pause the video right now and see if you can actually go through and check these boxes off yourself. But if that's not what you want to do, you can listen up. So, monocots, how many cotyledons do they have? Well, mono means 1. So what I want you to do in that cotyledon box is just put a 1. Okay. Now dicot, di means 2. That's very simple. We're going to put 2 leaves in there. Now next up we have venation. All right, we basically have 2 options. We can have parallel and we can have parallel venation and net venation. Now in monocots, I'm just going to put a P down here because that is definitely considered parallel. And in dicots, it would be considered net, so I'm going to put an N down there. Now flowering parts is a big portion of understanding the monocots versus dicots. Now flowering parts are going to be multiples of 3, and flowering parts in dicots are going to be multiples of 5. Now the vascular bundle arrangement for monocots is going to be considered scattered. So I'm just going to put an S down for that. And then in dicots, it's considered radial, which basically means it was kind of in that ring like that. Scattered is going to basically fill up that whole entire stem. So make sure you have this as kind of a little refresher chart in your notes. All right, finally what I want to talk to you about is how these seeds essentially survive. And over the course of time, call it evolution, call it adaptations, biological advantages, these seeds were genetically programmed to remain dormant until they experience the following. Now, to be dormant essentially means not germinating. So when these specific things that I'm going to mention here occur, these seeds will move out of being dormant and actually experience germination. Here's my first example. Receive faint light signals. Wheat is a great example of this. So wheat seeds will remain dormant, not germinating until they experience light. Another example would be desert plants. You notice this a lot. Once we get intense heavy rainfall during the rainy season in most deserts, that's when you will see those seeds begin to germinate. Another example would be the intense heat of a fire. Our forest plants, our conifers, our pine trees would be a great example of this. After an intense fire, a forest fire, you'll notice that the following year you'll have new growth sprout up. That is a biological process. A lot of people think that fires happen because it's man-made. A lot of times it's not. A majority of forest fires happen, lightning strikes, things like that, and it's supposed to occur. Another one would be total darkness. Avocados will remain dormant until they experience total darkness. So avocados can actually grow in the dark. That should remind you of some of the conversations we had with photosynthesis and the light and dark reactions. Finally, the last thing I wanted to bring up is lettuce. Cold followed by warmer temperatures. Lettuce is always something that'll grow well in our climate. Lettuce and broccoli, those are two that in the colder climates, once we start getting warmer temperatures, the seedlings will move out of their dormant state and begin germination. All right, to wrap things up with 11.2 seed germination, a couple questions to ask yourself. To this point, we should have defined what germination is. We looked at some major differences between monocots and dicots. We discussed venation. That's one of the things that we talked about. Venation is going to be how that nutrients moves in and out of the plant. And we looked at how it was arranged in monocots and in dicots. And finally, what are some factors that cause germination to begin? And that was that last slide that I went through. As always, if you guys have questions, feel free to ask any of your science teachers. Yago out.